Welcome to Sravz Technical Series. In today's session, we'll discuss the historical ticker plant implemented in REST, Session 2. In Session 1, we discussed at a high level the data flow diagram, how the ticker plant would look like, and then we discussed the REST application setup and interaction of NSQ and REST application. We demoed that. In today's session, we'll discuss the main module with the NSQ reader writer present, and then the router structure, which will act as a dependency injection container, which will hold services. And then today's service is with the leveraged funds of NASDAQ 100. For today, we'll just read the JSON historical tickers into a Polars data frame. And in a subsequent session, we'll do some analysis on that data. But for today, we'll just be reading the JSON files on S3 into Polars data frame in the REST application. I have redrawn the data flow diagram. So this is the data flow diagram. We would have the client browser in Angular, an Angular application using WebSockets connects to Node.js Socket.io server, which sends a message to NSQ message queue, which will send to the Rust ticker plant. The Rust ticker plant will get the NSQ message, and then using producer consumer concept, it will get the message, consume it, then send it to router, a dependency injection container. That NSQ message is sent to the service which can handle that message. The service will read the message, do a processing on top of the message, upload the payload to S3, and put the payload location in the message and send it back to NSQ. Send it back to the router sends it back to the main module sends to NSQ. So the client will know the payload, where the payload is located on S3, and that's how the Angular app will pull the message from S3 and display in the browser. So that's how the ticker plant will look like. And for today, I implemented the leverage fund services, but in future we'll implement more services, add more features which can leverage the ticker plant. So this architecture is similar to the the CPP REST APIs router controller service we discussed a while back. So if you want to go through a similar implementation in C++, it is located here. We did a similar implementation in C++. So you could go to C++ REST API router controller service section, where we had a router which acted as a dependency container of shared pointers, and then we had controllers like this and services. So we're following the similar architecture for the ticker plant. I'll switch back to the ticker plant. Like I mentioned, today's topics of discussion are ticker plant internal components, the main module, router, services, and demo of leverage fund service usage. Switch back to Visual Studio Code. I'll do a quick demo first so we know what is there. I'll go to the leveraged funds module, where we have leveraged fund structure, and then it implements some functions like this. So I'll run the test case first. So what we did is we have ETF tickers loaded to S3, which we did in a previous session again. In ETF historical codes uploader section, using Airflow, we uploaded the US ETF tickers historical codes to S3. So today we will be using the data in AWS S3, and we'll pick 3 tickers for now. The NASDAQ 100 funds, which are these funds, TQQ, QLD, QQQ. So we'll read those tickers from AWS S3 and then load each ticker to Polars data frame like we did here. We loaded TQQ. QLD, QQQ, and then we'll join all the three data frames on timestamp. So this way we'll have a single data frame with all three tickers. In the future section, we'll do analytics on this data frame. But for today, we just wanted to show that we're able to read the data from S3 and merge them into a single data frame. And also it's a test-driven development. So we have a test case here, which when run, it displayed this data. Now I'll go to the code base. We have the main module. And we'll skip the details of Rust implementation. For that, we'll have a separate video. Here, we'll just go through the Rust code base at a very high level. If you have any questions, you can ping in the message chat. So this is the main module. We have the consumer topic and the producer topic, training Rust, training Node. So the Rust application will be listening on the training Rust topic, and then sends a message after processing to the training node topic. Then we set up certain things for the NSQD to run, NSQ producer consumer to run. We have lookup the addresses saved to a hash set. Then we give the hash set to the consumer. And also we start the producer. Producer takes a single NSQD node. We have 3 NSQD nodes. So using random number generator, we pick a node randomly and then connect to that NSQD host. So when this Rust application runs in multiple instances of itself in a microservices structure, each node will pick an NSQ node at random. So that way we'll distribute the load to different NSQD daemons. So once an NSQD node is selected, it is connected to that. The producer will produce on that NSQD host. And then we get the messages. Once we get the message, we parse and all. We discussed that in the previous session. So once we get a message, we'll send it to the router in the process message function. In the process message function, we get the NSQD message, which is mutable. Since we are going to update the message with the S3 URL, we need a mutable instance of the message. So once we pick the mutable message, we'll check the function name in the message. So I'll go back to the message.json. We have the function name, leverage funds, NASDAQ 100. So the router will use that. The router will take the message name, compare it, and then it will call the appropriate service. In this case, leverage funds NASDAQ 100 message. We go to the leverage fund service. We set up the S3 bucket, and then using S3 client, we download the historical tickers for each of these 3 Sravz IDs, which is sent as an argument here. We'll loop through this argument. We looped through the args.clone. We'll discuss why we need to clone and all in a separate Rust specific program, Rust specific video. Here we just focus on the implementation of the ticker plant. So we get the object keys. Then to that we send the Sravz IDs. So it becomes an iterator. So for each of the Sravz IDs, we get the data from the historical ticker plant S3 location. And then once we get the data, which is gzip compressed, we decompress the gzip data. Once we decompress, we reformat the data so that it shows in the required format here. So then we get the old columns. We rename the old columns with the prefix of the Sravz ID. For example, if you look here, we added ETF just to the column name. That's because when we join three data frames with similar columns, it can join up to two columns, but the third data frame will throw an error because the rows are already, the column name is already existing. So that's why, to make the columns unique, except for date time, we change the column names of all other data frames. So once we do that, we create a data frame vector and push each data frame. So we have three data frames here. We pushed all of those into a vector, and in the end, we inner join each vector at a time, each data frame at a time on date time. So we'll loop through each data frame and we'll get this as the final data frame. Date time and TQQ columns are here, QQQ columns are here. The rest of the columns are omitted here, but if we print, we can see all the columns, or if we save to CSV file, we can see all the columns. So that's how we get a joined data frame. So in the subsequent sessions, we'll do some analytics, save this to S3, then send it back to the client via WebSockets. So we'll do all that in separate videos. So for now, I'll do another quick demo. I'll exit out of there and I'll run the application. The ticker plant will run, cargo run. And I'll demo the message passing via curl onto the Rust training-Rust topic. If you recall, in the first session we discussed, once we have the Node.js client running, Node.js will do this process. Once the client browser sends a message, Node.js will receive it, and Node.js will send the message to the training-Rust topic. But here, for today's demo, we'll just use curl. Once the service is up, we'll do the curl. Okay, so the service is up now. So I'll send the curl message. Message is sent. Okay. So it already processed the message. Let me put some new lines. Send the message. So it processed the message. The new lines are gone. So that's how the Rust application will receive the NSQ message and it will process it. So with that, I'll close today's session. If you have any questions or comments, please reach me out in this discussion tab here or in the YouTube channel. Thank you.